Welcome to Pneuma Systems. We're going to introduce a concept of technology called Pneuma Drive, which we put into a product called a Pneuma Flow Controller. This is intended to describe how we would use this in the administration of immunoglobulin and related products. So from a big picture point of view, we looked at current infusion pumps and we looked at gravity infusion. And the concept here was to avoid all the well-known hazards of gravity infusion and avoid the new hazards caused by traditional infusion pumps. So we've created a new category of infusion devices, not gravity, not a passive pump like an elastomeric or a spring-based pump, not a conventional electromechanical peristaltic or syringe pump, but really an entirely new category of pump. It's based on a technology that replaces dozens or hundreds of electromechanical components in an infusion device with a single platform that appears to be solid state, where there are no moving parts, it's quiet, it's inexpensive, and simple. So we will put this in a variety of configurations, but in one instance, it's a small battery-operated handheld device. We are ready to build this unit within 90 days, a fully functional, looks like, feels like complete medical device. It's a general purpose platform that can use various volumes and valves and pressure transducers in series with our novel pneumatic drive. And we've developed this in a very sophisticated development environment where we have control over all aspects of it to develop algorithms and for verification and validation. The core technology has to do with the interplay of volumes and pressures to allow us to measure both volume and flow. We're able to achieve a vast dynamic range, infusing at flow rates from a small fraction of an ml per hour to thousands of an ml per hour with very tight accuracy and control and fundamental measurements done in a very energy efficient environment. For immunoglobulin, here's a configuration where we have a manifold that's got a pneumatic connection. We're showing a flush syringe being connected to a disposable manifold. We then connect hyaluronidase as an example in this application. We connect the manifold to the device through a pneumatic connection. The line is primed using the pre-filled saline flush syringe. Instruct using the graphical display, adding a needle to the, having the patient attach their subcutaneous needle. We check for blood return by pulling back carefully on the line with the flush solution. And then we deliver the hyaluronidase to the patient. When it's complete, instruct them to remove that and attach the 10% IG. We deliver that, replace that bottle when it's complete, if needed, with a second dose. Complete the infusion, empty the line of IG, chasing it with exact amount of air to push all the IG out of the tube, remove the manifold, and we're complete. So the information management is as important as the fluid flow. So there's a secure cloud-based infrastructure that will allow the information to be managed. We're using the state-of-the-art kinds of secure cloud-based structures, and various caregivers can get any information they want from wherever they want, whether they're the pharmacist or the physicians or the patient caregivers. So that's it for a quick overview of our immunoglobulin configuration of the PneumaFlow controller.